You've felt this before, right? 90 degrees in a dry place, say Phoenix, can feel pretty bearable. But that exact same temperature in a place like Miami, suddenly it feels like you're walking through hot soup. So what's going on here? What's this invisible force that's completely changing how we feel? Well, it's all about what's hiding in the air itself. And yeah, that unseen force is atmospheric humidity. Today, we're going to do a deep dive into what it is, how we measure it, and why it affects literally everything from your own comfort to whether your favorite gadgets survive the day. All right, so here's the plan. First, we'll nail down that humid feeling. Then, we'll get into how it's actually measured. After that, we'll see how it impacts life and our gadgets. And finally, we'll wrap it all up with the big picture. Let's get right into it. Okay, so what exactly is this thing that makes the air feel so heavy and sticky on a hot summer day? Well, it all boils down to a really simple idea. See, at its core, humidity is just the amount of water floating around in the air. But it's not tiny droplets, it's an invisible gas called water vapor. It's pretty much always there, but the amount can be wildly different, from almost nothing in the driest deserts to, over 30 grams per cubic meter in the steamiest jungles. Now, here's where it gets interesting. There isn't just one single way to measure this dampness. Scientists actually have a few different ways of looking at it, and each one tells a slightly different story.
We're going to focus on the big three: absolute, relative, and specific humidity. Now, you've definitely heard of one of these way more than the others, but trust me, they each give us a unique piece of the puzzle.
So first up is absolute humidity. Just think of this one as the most direct, no-nonsense measurement. It's like if you could take a box of air, pull all the water vapor out, and just weigh it. It tells you the total amount of water that's there, period. And then we have relative humidity. This is the one you always see on the weather report. The key word here is relative, because it doesn't just tell you how much water is in the air, it tells you how full the air is compared to the absolute maximum it could hold at that exact temperature. And this is so important. Warm air can hold way more water than cold air can. It's kind of like a bigger sponge. And last, we have specific humidity. Now, this one's a bit more technical. It's mainly for the meteorologists and atmospheric scientists because it gives them a really stable number that isn't affected by changes in air pressure. It's a super useful tool for them when they're making weather models. So let's just boil it down. Absolute humidity tells you how much water is actually there. Relative humidity tells you how close to full the air is. And that's the key difference. It's why 50% relative humidity on a freezing cold day feels bone dry, but 50% on a blazing hot day can feel muggy because the total amount of water in that warm air is just so much higher. And that's exactly why relative humidity is the star of the weather forecast. When the air hits 100% relative humidity, it is completely saturated. It literally can't hold any more water vapor. That's the tipping point. That's when you get fog, dew, or even rain. It's a fantastic predictor. Okay, so we know it helps predict rain, but how does humidity affect us, personally? Let's get into why this water vapor matters so much to our own bodies. And here it is. This is the answer to that question from the very beginning. Our bodies have this amazing built-in cooling system. We sweat. That sweat is supposed to evaporate off our skin, and when it does, it takes heat with it. But if the air is already jam-packed with water vapor, if the relative humidity is high, your sweat has nowhere to go. It just can't evaporate, so it just sits there, and you stay hot and sticky. But it's not just our bodies that feel the effects. This invisible force can be a huge problem for our technology. And this is something a lot of people just don't realize. The weird part is, the danger comes from both extremes. If the air is too dry, low humidity, you get a ton of static electricity. If it's too wet, high humidity, you get condensation. And either one can be an absolute death sentence for your electronics. So let's just walk through the biggest danger here. Picture this. You take your laptop from a nice, cold, air-conditioned car and walk into a warm, humid house. Instantly, the cold surfaces inside your computer cause the water vapor in the air to condense into actual liquid water right on the circuit boards. And that can cause a short circuit and zap your device just like that. Now, on the flip side, what about super dry air? Low humidity is the perfect environment for building up static electricity. You know that little zap you get after walking across a carpet in the winter? Well, that same tiny spark of static discharge is more than enough to completely fry the delicate little components inside your computer. So yeah, it's pretty clear that humidity is way more than just a number on your weather app. It's a really fundamental force that shapes our environment, our own bodies, and even the tech we rely on. So what do you really need to remember from all this? First, humidity is just that invisible water vapor in the air. Second, Relative humidity is the one that tells us how full the air is. Third, it makes you feel hotter because it stops your sweat from working. And finally, remember that both super high and super low humidity are bad news for your electronics.
And that brings us to one final thought. We know the global climate is changing, and that means temperature and humidity patterns are changing right along with it. So the question we have to ask ourselves is, how is this powerful, invisible force going to continue to reshape our world, our comfort, and the technology we depend on every single day?